Once they verify it, is it coming live or not? Okay, right. Hello? And share me one more, that link also, live link. My WhatsApp. I want share me on WhatsApp. I want to observe that comments also. Okay, bro. Okay. Yes. Hi guys. A very good evening, everyone. Very good evening, guys. I hope everyone doing well. I think. Okay. For your kind reply, is it clear? Is it clear from my side? Just give me a clear. Just comment on clear. Okay, right. Okay, right. Shall we start the session? Okay, right. Okay. Before starting the session, I want to address about myself and my institution. This is Srikant from Pantech e-learning. So I'm having overall 3 years of experience on power electronic domain. So today we are going to be teach the topic about the EV designing. So we'll discuss briefly. Before starting the session, I want to just about my institution. So basically, I'm from Pantech e-learning. We are we are helping to students of their career guidance, and we are helping to their project completion and internships, and we are helping industrial equipment and same time industrial training. So these and all the particular domains from our office. So if you want any help in the future, don't hesitate to contact us. So right. So today we are going to be discuss about the topic electric vehicle design. So if someone asking what is electric vehicle designing, what is electric vehicle? So if you ask anyone, we have to say we know you know something about EV designing. So exactly what you know. So EV it's completely running by using battery something. So you know little bit, right? So we have basic idea about EV and something. So now we are going to be discuss from scratch. Like so if you have an EV vehicle, how the vehicle is working and what are the conditions and what type of parameters they are using. And same time, if we know industries are using what type of tools and how they are designing. We just observed how the vehicles are roaming and how the outside vehicles are roaming and all, but we don't know exactly what functions are involving in EV, what type of functions it will delivers, and what type of tools they are using. We can discuss from scratch, right? Right now, we are going to be depth mode. Just to encourage that, give me a thumb on your comment box. Now we are going to be started. Right. So if someone asking what is the definition of EV, like how you can define it. So uh, how you define the EV exactly. So if anyone asks you, we have to say. So EV it's a electric vehicle. It's a type of vehicle, but it's completely like whatever the motors, whatever the parameters, whatever the elements you are using, they're completely propelled or powered by using electrical energy, right? Here whole vehicle it will run by using electrical energy completely. So we know, especially we know how we are storing energy and something. So here we are storing the electrical energy on battery mode. So we have to store the energy on battery mode. So whenever we want to use, whenever we have to utilize the power from the battery, so we can transfer from the battery, and we can evolve, like we can completely transfer to the whatever, it need to be run the motor, it need to be run certain element. So here main theme of the EV part, here completely we are propelled, like we are completely utilized by electrical energy generally. That is called electric vehicle definition. So we know, so the main element of the main heart of the vehicle, it's a powertrain. Powertrain generally in technically we are called powertrain. It's a motor. So technically we have to pronounce technically we have to call as a powertrain. So powertrain is nothing but it's an automotive. Powertrain is an assembly of multiple components, like which works together to deliver power to an automotive mobile from the starting of the engine. Like powertrain only, it will be starting of the engine, and same time it will deliver to where the end of the wheels, like from starting to ending, completely capable the powertrain only. So that is the main word we are called powertrain. It's a complete capable of running element. Generally we are called powertrain. It's a complete capability of running element. So that is called powertrain. So here we are going to be run the powertrain by using electrical energy, right? That is called EV. We know already we are having a vehicles. Why we have to develop EV, why we have to focus on EV, why especially we are having petrol and diesel vehicles, why we are involving into, why we are stepping into electric vehicle designing. So here the some of the applications, just observe that. So by using EV, there is no use of here any petrol and diesel vehicles. Here completely no conventional fuel, no need of any fuel like any diesel or petrols or something. So we can completely depending on electrical energy. That is the main theme. So we know already how the how the levels of fossil fuels, how it reduced, how we are facing problems. So that is the main theme, right? And same thing, it cheaper to maintain comparing to petrol and diesel vehicles. It's very cheap, like not cheap, not like that word, like it is easy to maintain. So that's why we have to develop the EV part, and same time more eco-friendly and lower carbon footprint. So by using EV vehicles, we can't generate any harmful gases like any CO2 or any harmful gases to environment. So that is the main theme. Again, we are stepping into the EV part. And one more application, less noise pollution, right? It won't generate any pollution. It's completely pollution free, right? So that's why we have to step into EV part. That's why we have to develop into EV particle. So less noise pollution in the sense it won't generate any sound. So we already observed the vehicle is moving completely smoothly, like it won't produce any harmful sounds. So that's why this is the one more benefit, right? That's why we have to develop the EV. So here the some of the benefits of EV. So by using it's a energy efficient and same time reduced energy dependence. And one more benefit of the EV part is the regenerative braking. Regenerative braking in the sense, so we can like whenever we are applied on the certain brake particle of the EV, so it's automatically generates the power and again it stores on the battery. And same time easy to make autonomous in the sense, so like it's a automatic vehicle. So by using EV vehicle we can make a we can make a automatic vehicles, like no need of any driver. So driverless cars or driverless vehicles we can easily develop it. That is the one more benefit. And same time pollution free, so it won't generate any pollution. You already know that, right? So just observe the block diagram. So here the so by using this block diagram, how you are developing, how it involving, you already observed in outside the vehicles, like in roadside how the vehicles are moving and how it's moving forward. So exactly, just clearly observe the block diagram. See. So if you have any vehicle like a scooter or car, any something like any vehicle, you are going to be like run the vehicle, how it running, how it moving into forward. So whenever you are applying signal, like a signal in the sense, for bike it's like a accelerator, for car or something it's like a pedal signal. So same time, whenever you are applying the signal, then only it moving to forward, right? So exactly observe the block diagram. So here signal we are generating from the driver. So whenever signal we are giving to the motor controller, so whatever the signal we are generating, it will transfer to the motor controller. So motor controller only controls the motor, and motor only capable the vehicle body. You just observe the real time scenario. So whenever we are applying the signal, so we are having the motor particle, then whenever the signal generated to transfer to motor, automatically vehicle moving forward. So that is the main like main theme, main fund, like main function, how it working, how it involving, right? So here we are transferring the power supply from the battery. Just observe that, right? And same time, so how the industries are using tools and what type of tools they are using, how we are going to be design, how we are going to be develop that. And by using these tools, what is the use and how it involving into EV particle, like EV designing. So you are telling that designing or something, what is the use of this designing? So you have to know about first of all MATLAB tool, like what is that MATLAB, what is the function of MATLAB, what is the use, and especially where we are going to be used, and what are the types of MATLABs, like what is the applications of MATLAB. We can discuss from scratch. Don't worry about it. So how we have to start that step, and where we have to going to move, like where we have to in depthly how we can learn it. So everything from scratch. I want to give you source on something. Just observe that, right? So here just observe that product stages. Like here, just now only we are discussing about MATLAB, like what is the use of MATLAB and how we are going to be used. So just observe that, and you just remember this thing MATLAB. Now we can discuss about product stages. Like if you want to develop, like if you want to design, if you want to create any product, here we have to follow three steps. Like product, here we are going to be develop EV product, so you just leave it EV. You can choose any product. For example, you are going to be develop any, like for example any one pen. Just choose as a example, as a pen you are going to be develop that. How the company it will be developing. So first it collecting requirement from the customer, like how they are expecting, how those aspect ratio, like how much size, how much what type of ball pin we have to use. So for example we can choose that. So first we have to collect the requirement from the customer, like whatever the product. So we have to collect the requirement and we have to find the solution, right? So whatever the concept we are going to be developing, we are going to be find out the solution. Once you can verify the solution, we are going to be verify it. So for that, whatever the concept we are verifying, like for that only we are using simulation tools. So especially the tool is MATLAB tool. What is simulation? What is simulation involving? What type of blocks and what type of functions, how we are going to be design that. So right, whatever the product, here we have to find out the requirement, then we have to find the solution. That solution we have to verify it. Like here virtually we have to know the performance of the product. The product, whatever the product, it's not a problem, we are going to be verify that. So that's why here we are using the tool is MATLAB, right? So after you can verify it, like it behaves whatever the requirement of your customer or else you. So it behaves perfectly, then you can move into product and production stage. So that is the final stage. You got my point. So these are all the steps, like remember these three steps. Now we are moving into MATLAB. So here the some of the simulation tools. And MATLAB inside is a Simulink and CAD and Ansys, MATCAD, EMTP. These are all the simulation tools, right? So especially we are having multiple tools. Like industries are using a lot of different types of tools and multiple tools. But why especially we have to focus on MATLAB, and what is the use of that MATLAB? We can discuss from scratch, right? So here the MATLAB inventor Cleve Moeller. So he invented at a basic calculator 1980. Then he advanced into Simlink and Simscapes. So he can create into advanced models. So now currently we are using, it's a 2025, like 2025 version, like it's an advanced version. So now it's a MATLAB and Simulink. See what is MATLAB especially? What is the meaning of MATLAB? So MATLAB is a matrix laboratory, like it's a designing tool. By using MATLAB, what we are going to be design? What is the use? So MATLAB is a matrix laboratory. By using MATLAB, we can develop like numerical computing. It's a tool, actually it's a designing tool. By using MATLAB we can allow the matrix multiplications, manipulations and plotting functions, and data implementation of algorithms. Like we can create custom algorithms and same time. So here we can develop our own code in certain languages. So especially by using MATLAB, we can design it, and same time the main benefit, the main advantage of the tool. So here software side and same time designing side. Like if you want to develop any code of the custom code or custom algorithm, we can develop it in certain languages. And same time whatever the, for example, if you have one solution, like if you have one problem and any like a calculating part, so we can calculate easily by using MATLAB. And same time if you want to design that by using particular Simlink or Simscape tools, so you can easily design that. So that is the use of MATLAB. And if you want to involving into signal processing or else image processing, so we can easily manipulate it, we can easily develop that. So that is the use of MATLAB. Now we are going to discuss about Simscape and Simulink, right? by what is the exactly what is the meaning of Simulink and what is the meaning of Simscape. So Simulink is a one of the toolbox inside the MATLAB. So by using Simulink, we can create graphical programming environment for modeling, especially what type of modeling, and we can create multi domains. So multi domains in the sense, so we can create like electrical, mechanical and thermal, and same times mechatronics. So we can create easily, so we can design that. So that is the use of Simulink. So Simulink inside the environment, one more environment, it's a Simscape. It involving inside the Simulink only. So by using Simscape, we can create physical environments. So what is the meaning of especially physical? So what is the difference between a Simulink and Simscape? So here, so we can discuss deeply. See, so Simulink inside we can create especially certain logics, certain like if you want to create certain logic, or if you want to create any creation of any algorithm, so we can easily develop that. So in Simscape environment, here we are going to be develop that physical environment in the sense, there we can transfer in Simulink inside, we can transfer signals only from the block by block, we can transfer just signals. So here in Simscape environment, we can transfer the energy. Like, so for example, if you are using any thermal part of any block, so we can transfer that energy from the block by block. That is the use of main Simscape, right? So in the Simscape, what type of blocks are involving and how we are going to develop that, and what is the use, where we have to start these steps and all, and in our EV particle how it will involving, so we can discuss from scratch. Just observe this picture. So it's just like a it's a interface of the MATLAB. So like, so you can just follow my cursor. So here current folder, exactly which folder you are working here, working directory, it's workspace. So on same time, it's a command window. In this command window, if you want to create any command, if you want to give any command, here from that command you can get that, you can navigate into that command. And same time, here the workspace, and in this workspace what type of output you are observing. Here the current folder, which currently which folder you are working. So it's a just interface. Now you can involving into Simulink inside, it's a, just observe this. So here the blocks, whatever the blocks we are choosing, so we just observe the color difference. So here just observe the Simscape. So it easily measures that, like what type of environment we are going to be design, so we can easily knows the difference. And one more thing, in Simulink inside, we are going to be design only signals. We can transfer the signals from the block by block, right? It's a transformation function, especially in Simulink inside, it's a transformation function. We are transferring the signal from block by block. In Simscape inside also we are transferring not a signal. Here we are going to be transfer power, like energy, right? So whatever that model, whatever that domain, like if you are using mechanical or electrical or thermal, so whatever the domain we are following, so it will transfers. So here the interface, you just observe that. So here the window. So in this command window, we already discussed. If you want any command, you can give here the command, and it will opens that command and it will navigate it. So here the current folder, exactly which folder you are working, and same time, and here the workspace. So in this workspace, what type of work we are done like, so what type of work you are currently involving, so you can know that, right? Here the Simulink environment. In the Simulink environment, if you want to open that, so you can click here, automatically it will navigate to Simulink environment. Otherwise, if you want to open by command, you can just give as a Simulink command, it automatically open, right? So here you just choose that Simulink environment, and if you want to develop any particularly, if you want to go what type of blocks you want, so here we are having multiple domains, right? So I'm just choosing as a blank model. So in this blank model, so here the workspace, if you want to get any block or any something, So here the library browser, so we have to click on that library browser and we can grab that block or something, whatever the block. So here we are having different types of categories. So what type of block you are expecting, you can just click on that and you can get that block, and we are going to be start the designing, right? By using MATLAB, you can develop easily script part and graphical environment, and in Simlink and Simscape, and we can generate the signals, like what type of signals we need it. We can easily generate it. So here I am just having one script example. Here just is a one small equation, like it's a square plus b square, or else it's a plus b. So I'm having two elements, I need to add these two elements. We can easily develop that. We can easily know the answer. But how we are going to be implement as a block format, that is the main theme. So we having equations, so here by using equation we can convert into blocks we can convert into equations. So that is the main, our main main agenda, means main how we are going to be implement that equation to blocks. So that is the main aspect. So here I'm having small one more example, a square plus b square. So how we are going to be implement that? So by using here the constant blocks and same time square. So whatever the mathematical equation here happening, I'm choosing that certain blocks and all, and I can easily develop that. So we need a hands-on experience. So within one day we can't learn it, but based upon practice you can easily get that. And one more thing, we can generate the waveforms by using MATLAB. You can easily generate like a square wave, sine wave, and same time triangular wave. We know how, what type of waves, what type of power it measures, what type of signal it measures, right? So AC sine wave, like we see, it's a sine wave. So in the sine wave it will measure AC voltage. We know already. So DC it will measure straight wave, straight line, right? So these straight lines, like the by using these waves, how we are converting the power conversion. So we can discuss from scratch how we are going to develop that. So by using MATLAB, we can easily design that, right? Coming to next topic, power electronics, right? Coming to next topic, power electronics. Like what is power electronics and what is the use of exactly power electronics, and how the power electronics involving into our EV designing part. So here we are going to be design, I am going to be develop, I am going to be teach now, like what is power electronics and what are the types of semiconductor devices, and what is the application and MATLAB examples, and same time how it involving into our EV particle, our EV designing, right? Power electronics is that application of solid state of electronics to control and convert the power. So for example, so here by using power electronic device, whatever the device, like whatever the power conversion, we need to convert one mode into another mode, like on same time we have to control the power. So that is the use of power electronic devices. You just observe these. So here whatever the input I am having, so here the input by using solid state of switches I am going to be convert into another conversion. For example, here I am having AC wave, right? So this AC wave I am going to be convert and same time control it as adjustable DC, sinusoidal AC, or else high frequency AC. The main, by using that power electronic device we can convert into power conversion, right? See how that conversion involving, and how, what is the main, what type of solid state of switches we have to follow, what type of switches we have to use. So here my input was as AC input, right? And that AC input how I am converting as a half wave DC, half wave pulsating DC. See, by using power electronic device I'm going to be connected, like I'm going to be control it. See, we are having types of switches, especially solid state of switches. It's generally ideal switch, normal switch. So we know, so for example, we have to turn on any device, we have to turn on the switch. Whenever we turn on the switch, automatically it follows the circuit and it like transfer the whatever the connection on the circuit, and automatically we can run the output device. Same time, like that we have to, in our circuits having solid state of switches. So coming to those switches, MOSFET and IGBT. So by using MOSFET and IGBT, how we are, for example, in our circuit we are having any, in our control circuit or else conversion circuit, we are having any MOSFET switch. We know so MOSFET having 3 pin configuration, like drain, gate and source. So whenever drain gate, it acts as a input one, source as it acts as the output one. Whenever gate need a pulse, right? So whenever we are transferring, whenever we are applying the pulse, automatically it will turn on. Like whenever we are turn on the switch or else ideal switch, automatically output device it will work. Same format. So here, what are those pin configuration, how we have to apply the pulse, and how it involving, and same time how it showing that output element and all. So we have to know that, right? See, these and all the different types of power electronic devices. See, here that AC device we can convert into AC. For example, by using power electronic device, AC power we can convert into DC power. The power of conversion we are called rectifier power, and DC power we can convert into DC. It's a chopper. It will maintaining DC to DC power. DC to AC we have to convert into AC. The conversion of DC to AC we are called inverter. So okay, we know something about power electronics, and what is the use and how it involving in our EV particle and EV designing. We just observe this. So here we discussed about some of the applications. So for example, you are just assume as it's your EV particle, EV device, right? So for example, I am going to be charged like so completely. My input was as a battery it's a DC input, right? We know already. So I need to charge, it's a charging station having AC input. So if we want to charge the battery, we need to convert it, right? We need to convert AC to DC. So there we are using power electronic device. And same time, so here my, in my vehicle I am having that AC motor. You just assume it as a AC motor. If you want to run the motor, we need to convert the device, like we need to convert the power like DC to AC power. There we have to follow power electronic device as the inverter part. Got it? So these and all the different types of solid switches. By using these switches, we can convert the one more power, like one of the conversion into another conversion. Right? So here we are having the solid state of switches, diode or SCR, MOSFET and IGBT, GTO, SIC MOSFET. These are all the different types of solid state switches. So by using these switches, we can convert the one of the conversion to another conversion, and same time we can easily control it. You just observe that these and all the different types of application. You just look on one eye on these applications. Then we'll move into next topic. So now you understand like by what are the power electronic devices available. See here, the one of the power electronic device is a rectifier. Rectifier is converting AC to DC. We know, we just have an idea. Rectifier means what it will do. What is the function of rectifier exactly. So in rectifier we are having two types. Like again we are classified into control and uncontrolled rectifier. If you want to control the particularly voltage, like if you want to going to be control AC to exactly how much of DC output you want, we have to know as the AC analysis, sine wave analysis. Like here the sine wave. So sine wave it will indicate AC wave, like AC input. So for this input, how we are going to be convert exactly what range you want, what type of range or DC input, DC output you want. So before we have to know that AC sine wave analysis, right? So see here one cycle, like from it's a positive cycle and it's a negative cycle. One cycle need to be completed, it will take 20 milliseconds, like 0.2 seconds. So within 0.02 seconds it will easily complete one cycle, right? So for this conversion, how we are going to be exactly control it? So we have to use the formula. So here the frequency range we are using 50 hertz frequency. Time period t is equal to, if you want to calculate the time period, 1 by 50, it's a 20 milliseconds. So for example, you need to be control it only positive cycle, half of the positive cycle. So we have to mention this, whatever the fire angle, so we have to mention on that particular switch. We already discussed about the conversion of switches. We are using MOSFET switches. So there we have to apply particularly that gate signal, right? I hope everyone got it. Could you give me please kindly reply? Is it clear, everyone? Is it clear? I hope everyone got it. Maybe you don't have any doubts. Yes, yes. Right, right. Okay, right. See, here we are going to be use, here just simply I am using single diode rectifier. So I need to be control it. I need to be converted to only one cycle, like one sine wave cycle. There I am using single diode rectifier. We know by using the diode series we can control into AC to DC. See here the four wave diodes. So these circuits and all we are going to be develop on our MATLAB tool inside. So especially we are having only 1.5 hour time. So within 1.5 hour we can't show these examples as MATLAB examples. We can discuss completely our final model. So that's why I'm escaping these circuits inside the MATLAB how it's working. So if you want to know, if you want to get these details, please contact us. We can definitely provide a source or something, right? Right. If you particularly if you want to control the certain voltage range, here we have to follow MOSFET switch, like whatever the solid state of switches, right? So we can follow that switches and we can control that. So that's all about power electronics, right? I hope you have got it. Next, coming to next topic, inverter part. So, we already discussed what is an inverter. Inverter is a conversion of DC to AC. So, now we are going to be discuss inverter basics, types and the working principle and MATLAB demo, right? So, we already discussed how the inverter part is exactly involving in our EV particle, in our EV designing. See, inverter is a device, it's a conversion of DC to AC. So, for example, we are having DC power. So we are following as the AC motor. We have to control as the AC motor. We need to follow inverter device, right? So not only particularly not. So here we are discussing about EV particle. That's why we are especially point outing an EV designing. But if you want to, so we are having inverter multiple types, right? If you want to use as a home inverter, so there we can follow different types of inverter, right? So it will, if you are coming to our topic, if you want to run as a motor, as a AC motor, we have to convert a DC to AC, right? That is the inverter function. The device inverter is a device or power inverter or power electronic device as a circuit. It will converting, it will changes the circuit, it will changes direct current into alternative current. Got it? So just one more time, just observe the block diagram. We already discussed about the block diagram. So here we are applying the signal, we are transferring the signal from the control signal to motor controller, motor control to motor and vehicle body. So we are having as an input as a battery. So if you want to control, if you want to run as a AC motor, here especially the inverter device it will work. It will shows and it will runs, right? So we are having different types. So we can classify it into two types based upon load type and based upon waveform type. So based upon load type, again they are classified single phase, three phase, and based upon output waveform type. Like we are having different types of waveform type. So each waveform indicates a different specification, different range. It's a square wave, modified sine wave, pure sine wave. For example, we are going to develop as a single phase inverter. So here I am following as a MOSFET switch. Here the just observe this. Here my input as a DC input. We have to control DC to AC, how it will be, how what type of functions we have to give. So we know MOSFET. Here for example, here I am using as a MOSFET switch. MOSFET having three pin configuration. So these three pin configuration, what are those pins? Like a gate or drain source, and gate it's need a pulse. So especially we have to transfer the pulse. It's a PWM pulse. So for the function, like how the circuit is working, how we have to control that function exactly. See here I am controlling, I am turn on at a time two switches and at a time two turn off at a time two switches. So whenever the two switches turned on, the pulse it will transfer to the only two switches. And same time two switches will be turned off. So like that we can create into as a square wave, right? We can convert it to square wave. See, we have to know especially how the function, like how the circuit we are choosing, what type of blocks we are going to be choose. So this and all, if you want to learn something, if you want to learn these topics exactly in in-depth concept, you can just contact us and contact our institution. So we are providing internships or something. There we can discuss deeply. Same time it's a three-phase inverter. So we know. So it's a single phase inverter. If you want to use a three phase, same time you can DC power you can convert into the three phase AP output. Exactly, we can follow the three phase device output, right? So here the working principle. So one single phase having totally six switches. It will follows different degree mode of conduction. On single phase it will follows 120-degree mode of conduction. So there how many switches are turned on, here how many switches are turned off. So we have to know this in-depth concept and all, right? So here the three-phase wave configuration. So we can convert into DC to as a three-phase wave. So if you want to particularly design as a three-phase inverter, so here totally we have to follow six number of switches. So here we are having three phases, phase A, phase B, phase C, and each phase how the signal is transferred, how the signal we are converting, and which type of switches we are using, and which type of switch, and at what time, what type of switch it will turn down. You have to know these things and all. If you want to, you just observe this is a switching table. By using this switching table, we are going to be turn on and turn off those three switches or so to see in our circuit we are having totally six number of switches. So in that switch six number of switches at a time, first switch we have to turn on, remaining three switches turn on, remaining three switches turn off. So we have to follow switching table. Based upon the switching table, in which mode it will turn on, which mode it will turn off, we can easily turn on and turn off it, right? So here the mode 2. Exactly. You just observe the switching table in mode 2. What how which switch, which state of switch is turned on and which state of switch is turned off. You know that. Here mode 3. Right? So it's just a reference to develop a inverter part. So if you want to learn in-depthly concept, you can just contact us. Got it? Is it clear? So for your kind reply, is it clear? I hope everyone got it. Is it clear? Could you please give me a reply on the chat box? Is it clear? Yes, right. So here the applications. So here we are going to be involving as an EV designing part. That's why we are especially focused. We have to focus on motor application and same time home application industry. So there we have to follow different types of inverter system. Like we have to develop inverter part. So coming to next topic, DC to DC converter part. So it's a chopper. So if you want to develop that, what type of steps involving, what type of rules we have to follow. Just I want to show you something. So DC to DC converter is a unregulated power. It will be regulating. It will be purifying to as a regulated output. So by using this circuit, by using this device, we can easily convert the one more power of conversion to another conversion, right? So we can classify it into DC to DC converters based upon linear converter and same time hard switched converter, soft switched converter. So by using what type of switch we are using, so there we can create into different types. You just observe this block diagram once. So I'm just using as a non-isolated converter any converter. Here one of the converter is a buck converter. You know what is the meaning of buck? Like buck means it's a stepping down, right? You have to step down the power or step down the input. So here the input is a high range, output has a low range of amount. So if you want to develop that, what are the steps involving, what are the functions, right? See, in that converter we are having, for example, we are having uh, in our circuit we are having as a switch. So switch only it will be converting. You just assume as a it's a buck converter, right? So we input, and this input we are having one of the switch and same time one inverter and one capacitor. It's a load output. So here the switch, here the linear switch, what type of switch we have to choose. So here I am choosing as a MOSFET switch, right? See, you just observe this circuit diagram as a first circuit diagram. It's a non-isolated buck converter. Just you know that what is a buck meaning. It's a stepping down converter. And okay, right. Is it clear from my side? Is there any disturbance? Are you getting my voice? Is it clear? Right, guys. Could you please reply on that to your chat box? Okay, right. So I'm gonna just show you how the converter we are going to design in the tool. So we have to show as a demo part. I'm gonna show you. So here I'm going to be show as a buck converter. So we already know the buck converter circuit. So what are the switches here involving in the circuit? What are the elements? See, so one is it's a input one input to switch and same time diode and same time one inductor and one capacitor. How we are going to develop it particularly? So we know DC to DC converter is a regulated power supply. It will be regulating to unregulated power supply. It will be regulating. So I'm using buck converter. You just assume it's a buck converter. So he in my circuit having is a DC input one. So in the DC input I'm taking my input as a 24 volts. So especially I need to control as a 12 volts output. So how we are going to be controlling? How it involving? What is the process? So you just simply choose these blocks and all these and the sibling blocks from this library browser. So it's a MOSFET switch, diode and inductor and same time capacitor and resistor. So see, you just observe the output. Once I am already run my simulation, you just observe the output. See, here my input was 24 volts, here nearly 12 volts. I am controlling to 12 volts. How it's happening actually? How we are following? So we have to follow certain calculation in any circuit. whatever the circuit, whatever the type of circuit, it's not a problem. We have to follow calculation part, right? So here just observe that in my circuit I am having inductor and capacitor. We have to maintain those values, those parameters. Without those parameters you can't develop the circuit, right? So here I am just choosing my input was my input maximum input was a 24 volts. I need a output as a 12 volts, and in my circuit I have to maintain as a 2 volts, like 2 amperes current, right? So in my circuit I am having capacitor and same time inductor. So how we have to choose those parameters exactly? So here, so whatever the parameters, see what is the input, whatever the output minus V output into what is the current and frequency, what is the input range. We have to fulfill these values and all, and we have to calculate that. Then it will give certain particular parameters. So we have to exactly apply those parameters. Got my point? Right? So here for my capacitor, based upon this formula I got it 16.67 microfarad, right? So you just observe this. In my capacitor, what is that input parameter, right? If you want to control as a certain level of voltage exactly, so you have to follow the calculation part, and then only it will possible to control as a power part, like you control as a output voltage, right? So we can develop any kind of circuit. So I'm just show as the output, like as the example of buck converter. So converter, what type of converter design you are going to be developed, right? You can choose any converter, and for that converter we have to follow the same calculation formula, and you can develop that, right? Coming to next topic, motor. So here the motor is, so battery and motor only main heart and brain of the EV vehicle. We just simply assume as a battery as a brain of the EV and motor as a heart of the EV. So without these two elements, we can't imagine the vehicle, right? So here we are choosing time. What type of parameter of the motor we have to choose? So for example, what are the basics, what are the types of motors available, and how the parameters we have to choose in our vehicle, what type of motors we have to choose, right? So we have to know basics of at least the basics of motor. So we know motor is the electrical energy converting into mechanical energy. So for example, here we can classify it into two types in a motors: commutator motor and commutator based motors. So what is commutator and commutator-less? They here again they are classified into different types. You just observe that. So what is commutator and commutator-less motor? So commutator in the sense we are having before the input we are having the device. It's a commutator device. It will take the input from the commutator, then it will transfer to the motor as the output, right? So that is called commutator. You see commutator-less, there is no any commutator element. Directly we can create into magnetic field, and we can transfer to output to the output to the motor, right? If you are planning to choose any motor, if you are buying to any vehicle something, for example, you have to know basic parameters of motors, right? So here so motor power, like how much of power it capable, and same time motor torque in the sense you can just how much load it will be capable, and the speed, like rpm you have to know, revolution per minute. So within a minute how much revolution it will be completed, it will going to be complete, that we have to know these basic parameters and all, right? So here the different types of motors in EV. So one motor having one specification. Then here just normally we can choose from the motors from EV. So DC motor or induction motor, PMBLDC, permanent magnetic PA, brushless DC motor, PMSM, SRM. So based upon our requirement, we can choose the motor, right? So here it's a single drive system. So either front or rear, we can keep one motor and we can drive our system. So it's a dual drive. So comparing to single drive, having more capacity, having more sorry, having more range, like more power range. So comparing to single drive, it will move fast and it will performs better, right? It's all wheel drive, so each wheel having separate motor. So generally these type of these kind of vehicles we can observe on racing vehicles or something. So you can just observe this the picture of how the EV motors are like shows on real time scenario. See, and same time, that all about motor, and we are going to be now discuss about controller. So by using controller, we are going to be start and reversing and still speed controlling. And if you got any damage from the vehicle, you can directly it will directly indicate to the dashboard. So this is the main use of controller. So controller, it will perform the certain tasks on every vehicle. So we have to follow the controller part, right? 10 factors to choose electric motors for, especially why we have to choose. So it will reach as maximal speed and maximal torque, and it will runs only battery by using voltage or something. So that's why we have to choose the main motor part, right? So here the motor block available in MATLAB. So we are having different kinds and different application. So if you want to know in-depth knowledge, you just contact us. So coming to next part, a battery, right? So battery is a main. Battery is the brain of the vehicle. We already discussed it, right? So see, without battery, we can't imagine the EV designing part, EV vehicle. So what type of battery? What is battery definition? What type of batteries available? How we can create it, and how it's possible? So we know generally we are having two types of batteries: primary and secondary battery. Primary battery in the sense it's a rechargeable battery. Sorry, non-rechargeable battery. We can just use and throw battery, right? It's coming to secondary battery, it says rechargeable battery. We can charge multiple times, so like each battery having certain life cycles. So based upon the life cycles, we can charge it, right? Once the life cycle is completed, life cycle in the sense one time you can charge and discharge, one cycle completed, one life cycle completed. So like that we can classify it into batteries. It's a battery equivalent circuit. So we know battery is a chemical energy converting into electrical energy. So these are all the types. So in these types, so especially here we are using EV particle types: lithium ion, lithium phosphate, nickel metal hybrid, lead acid batteries. In that battery inside, what are the parameters, what are the uh, things available? So you can know here. It's just a case study, what type of vehicle, how much of the capability, and what is the range, you can know here. So if you want to know about battery in-depth knowledge, these things and all you have to know, like battery state of charge, depth of charge, and same time C rate, thermal voltage range. So these things and all you have to calculate it. For example, so certain range of motor you are choosing. So that range of motor, what type of range of battery you have to choose, you have to calculate and you have to know that. So without these things, we can't imagine to make, we can't imagine to develop that, right? So here we are going to be showing is a demo part. So especially, so you just assume as a battery configuration. It's a series and parallel configuration. What is that series and parallel configuration? So here we are going to be cell format. So each cell either a series or parallel connection. So based upon your requirement, we are going to be like develop that. See, we have to calculate the calculation part. So like within how much time it take, how much of voltage range, and how much of current it like maintaining. So we have to know these things and all, and then only it possible to develop that, right? Okay, right. So these things are about battery. So it's a cell arrangement. So you can create a requirement range and we can create that. So coming to vehicle modeling. So here we are going to be developed by using Simscape model, so we already know. So here those Simscape models, what type of blocks we have to choose, and how, what type of blocks we have to involving, like it's a thermal or electrical, or it's a what type of model, and we have to follow certain data, how much of data it will capable, how much of battery capacity, how much, what type of motor we have chosen, and what type of inverter converter device we need, we have to know that. So here the vehicle model, by using this model, either you are choosing uh, like it's a two-wheeler or four-wheeler vehicle, and we have to know these things and all, then only it's possible to develop that, right? And in our vehicle body, and like in our vehicle designing, we are having brake designing, what type of brake design available, it's a rear and front wheel. So how, what type of blocks we have to choose, and same time how it will be involving into our vehicle model, and same how we are going to develop that. If you want, I want to show you as a demo part, then you can understand, right? So these and all the motor parameter, and same time here we are following as a gearing system, what type of gearing system we are following. So here totally we are following three types of gears, right? How it will be converting that gear automatically, or based upon the time it will converting gear by gear, how it's shifting. So we have to know that gearing system. So here complete to coming to our model. So here we are going to be developed like battery and motor part, and same time vehicle body, gearing structure, and same time braking structure. So here separately we have to develop that, and we have to assemble it, and based upon their parameters, based upon our requirement, we have to develop this. Then you can observe that, right, how it's involving, how it's working exactly, what type, how it's behaving, right? I hope you everyone got it. So if you just give us a comment clear, everything was clear, then I am going to be sure as a demo part of the EV designing part. You just comment as a clear. Yeah, I will provide you that attendance link also. Just wait, like we are going to be finished. Yes, is it clear? Then I am going to be show as a demo part. Like we discussed about that battery and motor, and same time like vehicle body. So how we are assembling, and what type of output we have to observe it by using Simulink and Simscape environment. I'm going to be show now. So is it clear? Is it clear? Please could you give me as a reply? Is it clear? I hope everything was clear. Kindly give me a reply on chat box. Is it clear or not? Yes, yes. Okay, right. Okay, right. Now I am going to be show as a demo part of the EV. See, here we are already developing the model, and this model how we are involving, what type of parameters you have to choose it. So by micro parameters, I want to discuss. I want to show you. See, it's a battery pack. It's a PWM average, like it's a DC to DC converter. And here the motor, and the motor to gearing system, and braking system, and vehicle body. So it's like a subsystem. We are creating separately one subsystem, and now we are going to be reveal that, right? I want to show you. For example, here the my motor. So I'm just double click on the motor, and what type of parameters we are choosing the motor. See here here I am taking as a 72 volts of input motor, So here might the battery input, right? So it's a subsystem. If you want to know what type of circuit involving in the subsystem, you just double click on it and you can know that. So here it's like I'm creating cell format. Here totally I'm creating 18 volt cell configuration, and each cell it will gives the output as 18 volts from the each cell. 18 into 4.2, it's nearly 70 point something. So that's why I am especially 70 volt. My input requirement of the motor need at least 70 above, right? So after 70 to that 70 whatever the output 70 voltage, I'm again transferring to PWM average. It's a DC to DC inverter, like it's a DC to DC converter. If you are observing anything like unregulated power from the battery, so we can regulate from here. So then we can give to motor. There we can run on the motor. You just observe the color difference. So blue and green. Blue color component simscape environment. It's a simscape module. It's a simscape block. It's like it's indicating it's a electrical components. Green color is indicating mechanical component. So here we are combined those three multi domains, like those three two elements, and we are going to be observe them. Right? What type of power we are, like what type of parameters and what type of range you can observe here, how it's behaving or something. Then same in real time scenario, these parameters we are going to be choose and we are going to be involving and we are going to be develop that. Right? And coming to it's a gearing system. So in this gearing system, we are having actually low gear and middle gear and high gear, totally three gears. So here I am giving signal from the signal filter automatically. So whenever we are giving that signal to the gear system, automatically it will uh, based upon the time it will convert by gear. And same time we share the brake system. So here I am involving, here I am developing front and rear wheel model, and it's a vehicle body. So in this vehicle body, what type of tire you have to follow and how much of vehicle body capability, a totally four-wheel vehicle model. So you can observe that. I'm going to be run my model, then you can understand what type of parameters we are observing, right? See, now you are going to be understand the final terminology. What's happening exactly? So here my model. Here my I'm choosing a particular motor and particular parameters. And what's happening exactly? I'm following certain parameters and certain gearing system and braking system. Okay, you don't know like how it's involving, how it's behaving. So now we have to know that. So here just observe that I am following the time sample time within 34 seconds. See, within 34 seconds, here first gear. So you just observe that it's a speed maintaining. In this first gear, how it's maintaining the speed and same time based upon the time changing. In 10 seconds it's changing time, it's increasing the speed and same time again within 20 seconds it increase the speed and how much of speed it's maintaining. So it's nearly maintaining kilometer, like 80 kilometer per hour speed maintenance, and same time it will travels the distance nearly 144 meters within 34 seconds. Hope you got it everything. So then you can understand the parameters exactly here, right? I hope everyone got it. Still you have any doubt on that, we are going to be end the session now. So we are going, if you have any doubt on how we are developing and whatever blocks you have to choose, where you have to choose those parameters, how it's happening actually, so please don't hesitate to contact us. So take our contacts on the website and you can directly contact us, then you can know something, right? I hope everyone clear. Is there any doubt? I hope everyone was clear. Right? Still you have any doubts? Don't contact Chirag Sinha. Yeah, what's your doubt? Yeah, Chirag Sinha something. You already have my contact, like website contact number. You just contact us, and then what doubt you having, you directly reach out us, and you can know something. I hope everyone got it right. Okay. Are you guys? Did you fill that attendance link or not? Yes. Right, right, right. Okay. Shall we end the session now? Is there any doubt? Yes, yes. Hope you guys, everyone, understand clearly. So we are going to be in the session now. Is there any doubt, particularly on particular topic or something? If you clear everything, we are going to be in the session now. So attendance link. I hope uh, we already pasted attendance link on chat box. Could you please verify that? Yes, yes. Yeah, yeah. We'll provide you wait some time. Just wait. Yes, yes. Okay, right. Right, I think hope you everyone got it. So we are going to be end the session. Still, you have any doubts on particular topic or something? So you have already our contact, our website contacts. Don't hesitate to contact us. Right. Thank you for the chance. Thank you guys. Have a good day.